Hey there, science fans! Welcome to our deep dive into the world of protein-based medicinal formulations. These aren't your average vitamins we're talking about. These are powerful medicines derived from proteins carefully designed to treat a wide range of conditions. Now, you might be thinking proteins, like in my chicken nuggets. Well, sort of. But these proteins are specifically chosen for their therapeutic properties. Today, we'll explore how adsorption, that's right, adsorption, impacts the stability, efficacy, and shelf life of these complex macromolecules. Get ready to explore the fascinating world of proteins and how they behave in medicines. Picture this: you've got your protein-based medicine, carefully packaged and ready to work its magic. But what if I told you that, over time, the very ingredient responsible for its healing power could start to disappear? You wouldn't want that, right? Well, that's where adsorption comes in. You see, proteins have this sticky personality. They love to cling onto surfaces like the walls of their container. It's like they're trying to make new friends, but it's not a party we want them attending. This sticking action, known as adsorption, can lead to a reduction in the available therapeutic concentration. Less medicine in action means less effective treatment. We're talking suboptimal dosing and reduced efficacy. Not cool. But it's not just about the medicine losing its punch. Imagine those adsorbed proteins piling up on the container surface. It's like a microscopic traffic jam in there. This buildup can also accelerate degradation processes, further reducing the potency of the medicine over time. So not only are we losing active ingredients, but the ones left behind might not be in their prime fighting form. We need to keep those proteins in check and make sure they stay off the walls and in the game. Proteins are like tiny, intricate machines, their shapes carefully crafted to perform specific jobs. But imagine our protein hero, all ready to fight disease, suddenly getting twisted and tangled. That's what can happen with adsorption. When proteins get too clingy with surfaces, it's not just a harmless hug. It's more like a wrestling match they didn't sign up for. This forced interaction can cause them to unfold and lose their unique three-dimensional structure, a process called denaturation. Now, a denatured protein is like a deflated balloon. It's lost its mojo. It can no longer carry out its intended function, rendering the medicine less effective. And to make matters worse, this shape-shifting can also trigger the immune system. You see, our bodies are great at recognizing and fighting off foreign invaders. When a denatured protein shows up looking all wonky, the immune system might mistake it for a threat and launch an unnecessary attack. That's why understanding and controlling adsorption is crucial for the safety and effectiveness of protein-based medicines. We've seen how adsorption can make proteins disappear and change shape, but hold on to your lab coats because it gets even more interesting. Remember those sticky proteins clinging to surfaces? Well, they're not content with just hanging out alone. They can act like tiny magnets, attracting other proteins in the solution. It's like a microscopic dance party, but instead of grooving, they're forming clumps. These clumps, known as aggregates, are bad news for a couple of reasons. First, they can clog filters used in the manufacturing process, making it difficult to produce a consistent and high-quality medicine. Second, and more importantly, protein aggregates can trigger an immune response in patients. Remember, our immune system is always on the lookout for anything that seems out of place. When it encounters these large protein clumps, it can go into overdrive, causing inflammation and other adverse reactions. Chapter 4. A supporting cast, the role of excipients. We've seen how adsorption can be a real party pooper for protein-based medicines. But fear not, because scientists have developed clever strategies to combat this sticky situation. Enter the excipients, the unsung heroes of the pharmaceutical world. Excipients are inactive ingredients added to formulations to improve their stability, solubility, or delivery. Think of them as the stage crew for our protein stars, making sure everything runs smoothly. One way excipients combat adsorption is by competing with proteins for those coveted surface spots. Imagine a game of musical chairs, but instead of chairs, we have binding sites on the container surface. Excipients, like surfactants, can swoop in and occupy those spots, preventing the proteins from sticking. Other excipients act as bodyguards, surrounding the protein molecules and shielding them from interacting with surfaces. They're like tiny bubbles of protection, keeping our protein heroes safe from harm. Let's face it, sometimes you can't change a protein's sticky personality, but what if we could trick them into thinking those container surfaces are less appealing? That's where surface modification strategies come in. It's all about changing the playing field. One approach is to coat the container surfaces with a material that proteins find less attractive. Think of it like putting up no trespassing signs for our sticky friends. Another strategy is to adjust the pH of the formulation. Remember how proteins have that special three-dimensional structure? Well, pH can influence that structure, making them more or less likely to stick to surfaces. It's like finding the sweet spot where proteins are most comfortable and least likely to cause trouble, and if all else fails, we can always resort to good old-fashioned filtration. By passing the formulation through special filters, we can physically remove any protein aggregates that have formed, ensuring a clear and potent medicine. So far, we've mostly talked about adsorption as the villain in our protein-based medicine story. But what if I told you that sometimes we can actually use adsorption to our advantage? That's right. In the world of drug delivery, adsorption can be a powerful tool for achieving targeted delivery and prolonged circulation times. Imagine this. Instead of trying to prevent proteins from sticking to surfaces, we can design drug delivery systems like nanoparticles or liposomes that specifically bind to certain tissues or cells. It's like attaching a GPS to our protein medicine, guiding it to the exact location where it's needed most. By controlling the adsorption properties of these delivery systems, we can ensure that the drug is released gradually over time, maintaining therapeutic levels for longer periods. This targeted approach not only improves efficacy, but can also reduce side effects by minimizing exposure to healthy tissues. When it comes to medicines, safety is the name of the game. That's why regulatory agencies like the FDA here in the United States have strict guidelines in place to ensure that protein-based therapeutics are safe and effective. And guess what? Adsorption plays a key role in meeting those regulations. Before a new protein-based medicine can hit the market, scientists must thoroughly characterize its adsorption behavior. They need to understand how it interacts with different surfaces, what factors influence adsorption, and how it might impact the quality and stability of the drug product. This involves a battery of tests and analyses to assess things like aggregation potential, immunogenicity, and degradation pathways. It's like giving the medicine a thorough background check to make sure it's up to par. By carefully studying and controlling adsorption, we can minimize risks and ensure that patients receive the full benefit of these innovative treatments. So there you have it, science fans. We've journeyed into the fascinating world of protein-based medicines and explored how adsorption can be both a challenge and an opportunity. Understanding and controlling protein adsorption is crucial to developing stable and effective protein-based medicinal formulations. From preventing denaturation and aggregation to designing targeted drug delivery systems, scientists are constantly innovating to overcome these hurdles and unlock the full potential of these powerful therapies. Stay tuned for more insights into the fascinating world of pharmaceutical science.